Here we are at the last lesson of Chapter 1, applying the Pythagorean Theorem. Understand how to apply knowledge of the Pythagorean Theorem to real-world problems. So after all of those understanding, learning, proving of the Pythagorean Theorem, we're finally going to apply it to real-world problems. And that's going to be very exciting, so let's go. As we go through this lesson, the two goals I want you to come out of this video with is, first, learn to use the Pythagorean theorem to find the shortest distance between 2 points in a three-dimensional figure. Second, is able to use a Pythagorean theorem to solve problems in real life. So here is an animation. So the puppy at point A wants to get to the sausage at point B as fast as possible. He chooses route AB instead of AC, then AB, then CB, then CB. How come? Why did he choose that? Why did he choose a red route instead of the blue one? Well, because AC plus CB is greater than AB, the shortest distance between 2 points is going to be the straight line. We learned about this last year, more than once actually, so I expect you know that. If you're not, you would probably want to go back and I'll put the link in the description below. So think, in a 3D shape, what would be the shortest distance between two opposite vertices? So here's what I mean. If you have alright, so if you have a shape like this, a rectangular prism, and you wanted to find the distance between this point and this point, the shortest distance, how would you find that? Well, we're about to find out. The shortest distance between two vertices. Question. On a cylindrical stool, if Selma left a little food at B while eating, it happens that an ant at A caught this and wants to crawl from A to B. What is the shortest path the ant would have to go? So these are all the possible paths from A to B. You can travel up that way or straight ahead that way. So which path would be the fastest? Well, we can make this into a net figure. So at the very first chapter back in 7th grade, we learned all about how we can turn a 3D figure into a two-dimensional one. So if you go like this, you'll see without the bases, you'll see that it's just a rectangle. And A to B is just like that. So given that the height of the cylinder is 12 centimeters, the radius of the bottom surface is 3 centimeters. And if we take pi as 3, then AB squared is equal to 12 squared plus 3 times 3 squared. So AB is equal to 15. So here's a method conclusion. First, you find the shortest distance between 2 points in a three-dimensional figure. Generally expand the three-dimensional figure into a plane figure. Connect the 2 points and determine the shortest route based on the shortest line segment between the 2 points. And if you think about it, it's really just a right triangle right here. So, yeah, it's always good to keep in mind the Pythagorean theorem. Let's do some practice. Example 1. There is a cylindrical oil tank. A ladder would be built around the oil tank at point A and ends just above point A at point B. How many meters does the ladder need? It is known that the bottom radius of the oil tank is 2 meters, and the height of AB is 5. And then we can round pi to 3. So how would you do this? Using what we just used for the last problem, I want you to try to figure this out by yourself. Okay, so first we're going to cut this out and become a rectangle. So then really what this is this is all around the cylinder, so it would look like this. So here's the solution. The expanded view of the oil tank is shown in the figure, and A prime B prime would be the shortest distance of AB prime would be the shortest distance ladder right here. So because A prime is equal to 2 times 3 times 2, which is 12, A prime B prime equals 5, so AB prime equals 13. That is, the shortest ladder needs to be 13. Applying the Pythagorean Theorem. Uncle Hart wanted to check whether the A side and B side of the front of the sculpture base were perpendicular to the bottom side AB, but he only brought a tape measure with him. Can you find a way to complete the task for him? Well, first we can draw this line. So to connect diagonal AC, just measure the length of AB and BC, and you'll get AC. So we know that AB squared plus B squared equals AC squared. Actually, we want to test if that's true. So if this is true, then triangle ABC would be a right triangle, if it was true. So the way he would find it was just use a tape measure, measure CB, AB, apply the Pythagorean theorem, and if the Pythagorean theorem solves it, then it means that it is a triangle. And this is what we learned in the last lesson. If it applies to Pythagorean theorem, it must be a right triangle. 2. Measure that the length of AD is 30 centimeters, the length of AB is 40 centimeters, and the length of BD is 50 centimeters. Is the AD side perpendicular to the AB side? I want you to try to solve this up. Alright, so here's the method. So AD squared plus AB squared equals 30 squared plus 40 squared, which is equal to 50 squared, which is equal to BD squared. So angle DAB equals 90 degrees, and the AD side is perpendicular. So here's how we can analyze word problems with mathematical thinking. We can first turn the word problem into a math problem by modeling. So method conclusion, the key to solving such problems is to transform actual problems into mathematical problems. In the mathematical model, right triangle, apply the Pythagorean theorem or the inverse Pythagorean theorem to understand the class summary. Applying the Pythagorean theorem, we learn about the shortest distance between 2 points in a 3-dimensional figure and the real-world applications of the Pythagorean theorem. And the 2 skills you should end with today is learn to use the Pythagorean theorem to find the shortest distance between 2 points in a 3-dimensional figure, is able to use the Pythagorean theorem to solve problems in real life. So I hope you enjoyed our lessons from chapter 1, and I'll see you in the next chapter.